So for this question, we have a block pulled with a force of 25 newtons, and that's going to be at an angle of 20 degrees above the horizontal. And we need to find the work done by the pulling force when we're pulling it for a distance of 15 meters. So a few things to think about with this. One, we can just plug it into our main equation, which is work equals force times displacement cosine theta. We also need to understand that in terms of this force, we could break it into its x component and its y component. We would say that this is the positive x direction, that's the positive y direction, and understand that the component that's doing work is the x component. The y component would be doing no work because it's perpendicular to my displacement. And so if this is my angle here, really to find the x component, we would use cosine of theta equals the force in the x divided by force. So really the force in the x equals the force times the cosine of theta. And so, if we're just talking about the x component, then the angle between the x component and my displacement is 0. But if we're just dealing with this in total and we're just going to use the main force, we're really going to get the same thing, because look, the main force times the cosine of theta is the x component, and x component times our distance of 15 is going to be our work done as well. So it really doesn't matter how we think about this. Really, it's set up already for us just to plug in our numbers. A pretty straightforward question. So we're going to have 25 newtons, displacement of 15, and our angle between our displacement and our force is going to be the 20 degrees. When I plug all those in, I'm going to get a work done of 352 Newton